In exercise 3.4, we have to solve the pair of linear equations by elimination method. Now, in first part of question number first, two equations are given to us. First one is x plus y equal to 5 and second one is 2x minus 3y equal to 4. In elimination method, first of all, we have to eliminate or remove any one of the two variables by making its coefficient equal. Now here I am making the coefficient of y equal in both the equations. Now here coefficient of y in equation first is 1 and coefficient of y is in equation second is minus 3. So, and LCM of 3 and 1 is 3. So we will make the coefficient of y in both of these equations as 3. Now on multiplying equation first by 3, we will get the coefficient of y as 3. So we will multiply the first equation by 3. Now this will give us 3 into x will be 3x plus 3 into y will be 3y equal to 3 into 5 will be 15. Now second equation will remain the same, that is 2x minus 3y equal to 4. Now we have to eliminate variable y from these two equations. Now as we see here, the sign of coefficient of y in both the equations is different. So we will add these two equations. Now we are adding equation first multiplied by 3 with equation second. Now this will on adding, this will give us 3 plus 2 will be equal to 5x and plus 3y minus 3y will cancel out and that will be 15 plus 4 equal to 19. Now that will give us x equal to 19 by 5. Now after getting the value of one variable, we will put the value of variable x in any of these two equations, whichever is more convenient. So I am putting the value of x in equation first. On putting value of x in equation first, now that will give us, in place of x we will take its value, that is 19 by 5 plus y equal to 5. Now y will be equal to 5 minus 19 by 5. Now after taking 5 as LCM, we will get it as 25 minus 19 and this will give us 6 by 5. So we can say thus x is equal to 19 by 5. Here we have obtained the value of x, that was 19 by 5, and y will be equal to 6 by 5. Now in third part of question number first, the first equation is 3x minus 5y minus 4 equal to 0. And the second equation given to us is 9x equal to 2y plus 7. Now we will write the second equation in the same form, in the form of the first equation, and that can be written as 9x minus 2y minus 7 equal to 0. This is our second equation. Now again, here I am eliminating the variable x. Now here the coefficient of variable x in equation first is 3 and in equation second it is 9. As we know, LCM of 3 and 9 is 9. So we will convert the coefficient of x into 9. Now equation first, if we multiply this 3x by 3, that will give us 9x. So we will multiply equation first by 3. On multiplying equation first by 3, and now here the sign of coefficient of x in equation first is positive and in equation second it is also positive. So both the equations have same sign of the variable which we are eliminating. So we will subtract these two equations. Now equation second. So on multiplying equation first by 3 and subtracting it by equation second, we will Now first of all we will multiply it by 3. 3 into 3 will be 9x minus 3 5 is 15y minus 3 into 4 will be 12. And second equation will remain the same, as we are not multiplying it by any variable, or we can say we will multiply it by 1, as it is already 9 here. Coefficient of x is 9, and equation first we have converted the coefficient of x into 9. Minus 2y minus 7 equal to 0. Now we have to subtract these two equations. We have to subtract the second equation by first equation, so we will change the signs of second equation. Now this was positive, positive will become negative, negative will become positive, and negative will become positive here. Now plus 9x minus 9x will cancel out. Now minus 15 plus 2y will give us minus 13y, minus 12 plus 7, that will be minus 5 equal to 0. Now this will give us minus 13y equal to 5, and value of y will be minus 5 by 13. Now we can put the value of y in any one of the equation, either first or second. I am putting the value of y in equation first. On putting value of y in equation first. Now if we put the value of y in first, now our first equation is 3x minus 5y, and in place of y we will write down the value of y, that was minus 5 by 13, minus 4 equal to 0. This will be 3x plus 25 by 13. Now minus 5 into minus 5 will be plus 25, minus 4 equal to 0. Now 3x will be equal to 4 minus 25 by 13, and that will be 52 minus 25 by 13, and that will give us 27 by 13. Now this was the value of 3x. 3x equal to 27 by 13, so x will be 27 by 13. On dividing both sides by 3, we will get it as 3 9s are 27, and that will be 9 by 13. Thus we can say here the value of x is 9 by 13 and value of y is minus 5 by 13. In fourth question, the first equation is x upon 2 plus 2y by 3 equal to minus 1. So first of all, we will convert this into standard form by taking its LCM. Now LCM of 2 and 3 will be 6. Now this will be 3x plus 4y equal to minus 1. On multiplying both sides by 6, we will get, or you can multiply 6 with minus 1, we will get 3x plus 4y equal to minus 6, and this is our first equation. And second equation is given to as x minus y upon 3 equal to 3. Here also we will take the LCM, and this will give us 3x minus y upon 3 equal to 3, or we can say this will be equal to 3x minus y equal to 9. Now as we see here the coefficient of x is already equal. Now here in equation first the coefficient of x is 3x, and equation second the coefficient of x is 3x. So we can easily eliminate the value of x here by subtracting these two equations. Now on subtracting equation second by equation first, so this will be 3x plus 4y equal to minus 6, that was our first equation, and 3x minus y equal to 9 is our second equation. Now we will subtract these two. Now the positive will become negative, plus and minus. Minus 3 plus 3x minus 3x will cancel out, plus 4y plus y will give us 5y, and that equal to minus 6 plus minus 9 will be equal to minus 15. So that will give us y equal to minus 15 by 5, that equal to minus 3. Now on putting value of y, now we can put this value in any one of the equations. I am putting it in equation second, y in equation second, and our second equation was 3x minus y equal to 9. So that will be 3x minus y. In place of y, we will put the value of y, that was minus 3 equal to 9. And this will give us 3x plus 3 equal to 9. Or you can say this will be equal to 3x equal to 9 minus 3, that equal to 6. Or you can say x equal to 6 by 3, and that will give us 2. So thus we can say x is equal to 2 and y equal to minus 3. Now in question number 2, from a pair, form the pair of linear equations in the following problems and find their solution if they exist by elimination method. Now first of all, we have to check whether the solution of the problems exist or not, and then if exist, then we will solve it by elimination method. Now in first part of question number 2 is, if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes 1 by 2 if we only add 1 to the denominator. What is the fraction? Now here, as we know, fraction has two parts, numerator and denominator. So we will take numerator as x and denominator as y. Suppose numerator of fraction be x and denominator be y, then the fraction will become numerator upon denominator, that is x upon y. Now in first part he is saying, now case first, now our fraction was x upon y, and here it is given to us that if we add to the numerator, now if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. Now this fraction reduces to 1. Now we will solve this equation. Now this will be x plus 1 equal to 1 into y minus 1 will be y minus 1, and we can say this will be x minus y will be equal to minus 1 minus 1, and this will give us x minus y equal to minus 2. This is our first equation. Now case second, in case second it is given to us that it becomes 1 by 2 if we only add 1 to the denominator. Now if we add only one only to the denominator, then the fraction becomes 1 by 2. Now that means this will be 2x after cross multiplication equal to y plus 1, and this will give us 2x minus y equal to 1. This is our equation second. Now we will solve it by elimination, but first of all we will check whether the solution of these two linear equations in two variables exist or not. For that, in equation number 1, the coefficient of x is 1 and coefficient of y, that is b1, equal to minus 1, and constant term c1 is minus 2. Similarly, in equation second, the coefficient of x is 2, that we will take as a2. Coefficient of y, b2, is equal to minus 1, and c2, that is constant term, is equal to 1. Now a1 by a2 is equal to 1 by 2, and b1 by b2 is equal to minus 1 by minus 1, that equal to 1. As we see here that a1 by a2 is not equal to b1 by b2. Now, if ratio of the coefficient of x and y are not equal, that means a1 upon a2 is not equal to b1 by b2, then the given pair of linear equations, so the given pair of linear equations has unique solution or exactly one solution. Now, we will solve these two equations by elimination method. Now, as we see here, in equation first was x minus y equal to minus 2 and equation second was 2x minus y equal to 1. Here, coefficient of y is equal in both of these equations, so we can easily eliminate them. Now, also, here the sign of coefficient of y is minus 1. Yeah, you can say the sign is negative, and here also in equation second the sign of coefficient of y is negative. So the sign of the coefficient of y in both the equation first and second is same, so we will subtract them. So on subtracting equation second by first, here we are subtracting this one, so sign of 2x, y and 1 will change. Now x minus 2x will give us minus x plus y minus y will cancel out, and minus 2 minus 1 will be equal to minus 3, and we can say that x equal to 3. Now on putting value of x in any of these two equations, we will get the value of y. On putting value of x in equation first, now equation first was x minus y equal to minus 2. In place of x, we will write down the value of x, that was 3, minus y equal to minus 2, and that will give us minus y equal to minus 2 minus 3. This will give the value of minus y as minus 5, and that will be y equal to 5. Now thus fraction is equal to, now fraction was equal to x upon y, and value of x what we have obtained is 3. Value of x is 3 and value of y is 5, so fraction will be 3 by 5. Now in second part of question number 2, 5 years ago Noori was thrice as old as Sonu. 10 years later, Noori will be thrice as old as Sonu. How long was Noori and Sonu? We will take present age of Noori as x and present age of Sonu as y. Now 5 years ago, age of Noori was thrice the age of Sonu. So 5 years ago, the age of Noori was x minus 5 as her present age is x. Now similarly, present age of Sonu is y, so 5 years ago his age was y minus 5. Now in the relation given in our question is age of Noori is thrice the age of Sonu. That means x minus 5 equal to thrice of y minus 5. And after solving this, we are getting an equation x minus 3y equal to minus 10. Now the second relation is that 10 years later, age of Noori was will be twice the age of Sonu, and the present age of Noori is x, so after 10 years her age will be x plus 10. Similarly, present age of Sonu is y, so after 10 years his age will be y plus 10. Now second relation was that age of Noori is equal to twice the age of Sonu. The age of Noori is x plus 10. X plus 10 is twice of age of Sonu, that was y plus 10, and that is giving us an equation as x minus 3y equal to 10. Now in equation first and equation second, if we see here, the coefficient of x is equal. That means we can easily eliminate x, variable x, from here by subtracting these two equations. Now before that, we have to check whether these two linear equation in two variables has a unique solution or not. Here coefficient of x is 1, and in equation second coefficient of x is 1. So 1 a1 upon a2, that is 1 upon 1 will be equal to 1. Similarly, coefficient of y in equation first is minus 3 and coefficient of y in equation second is minus 2. So minus 3 upon minus 2 will give us 3 by 2. That means b1 upon b2 is not equal to a1 upon a2. That means these two equations have a unique solution. Now here we are solving them by eliminating the variable x. Now we will subtract equation second from equation first. That will remove the variable x. Now on subtracting equation second by equation first, we are getting y as 20. Now we can put the value of y in any one of the equation first or second to get the value of x. Here I am putting the value of y in equation first, and that is giving us the value of x as 50. As x was the present age of Noori, that means present age of Noori is 50 years, and y was the present age of Sonu, and that is coming 20 years. That is present age of Sonu is 20 years. Now come to part third of question number second. The sum of the digits of two-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. Now for any two-digit number, suppose we are taking a two-digit number 35. Now for this 35 can be written as 30 plus 5, or we can say this will be 3 into 10 plus 5. Now if we take the 10th digit of a number as x and unit digit as y, that means here we are taking this 3 as x and 5 as y. So we can say this two-digit number can be written as x into 10 plus y, or you can say in simple it can be written as 10x plus y. So we will take the 10th digit of our two-digit number as x and unit digit as y. Now if 10th digit is x and unit digit is y, then the two-digit number will be 10x plus y. Now here it is saying that the sum of digits of two-digit number is 9. Now sum of digits is 9, and here the digits are x and y. That means x plus y is equal to 9. This one is our first equation. Now the second relation is 9 times this number is twice the number obtained by reversing the order of the digits. For that, first of all, we will find out the number obtained on reversing the digits. Now the number was 10x plus y. If we reverse the digits, that is, if we make y as the 10th digit and x as the unit digit, then the number will be 10y plus x. Now he is saying that 9 times this number. 9 times this number means 9 times 10x plus y is twice the number obtained on reversing the digits. And number obtained on reversing the digits was 10y plus x. Now we will solve this to get the second equation. And the second equation we are getting is 8x minus y equal to 0. As we see in first and second equation, here coefficient of y is plus 1 and here coefficient of y is minus 1. The coefficient is same, numerical value of the coefficient is same, and one is positive and another one is negative. So we can easily eliminate y by adding these two equations. Now on adding equation first and second, now equation first was x plus y equal to 9 and equation second was 8x minus y equal to 0. Now on adding these two equations, y will eliminate and we will get 9x equal to 9, and that will give us the value of x as 1. Now we can put this value of x in equation first to find out the value of y. X plus y equal to 9 was our first equation. So in place of x we will take 1 plus y equal to 9, and that is giving us y equal to 8. Thus the two-digit number is, now two-digit number we have taken was 10x plus y, and value of x is 1 and value of y is 8. So it will be 10 into 1 plus 8 and that is equal to 18. Now fourth part of question second. Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and 100 she received. Now we are taking the number of rupees 50 notes she received be x and number of rupees 100 notes she received be y. Now total number of notes she received was equal to 25. That means x plus y will be equal to 25. Now she withdrew rupees 2000. Now there were x notes of rupees 50 and their total will be equal to 50x plus. Now similarly she received y notes of rupees 100, so total will be 100y, and the sum of these two is equal to total sum, that was 2000. Now here these two equations can be divided by 50. Now this equation can be divided by 50, so x plus 50 to the 100 and that will be 50 into 40 will be 2000, and this is equation second. Now here the coefficient of x is same, so we can easily eliminate x by subtracting these two equations. Now on subtracting equation second by equation first, we are getting y as 15. Now on putting value of y in equation first or second, now here I am taking equation first. On putting the value of y in equation first, we are getting x as 10. That means number of 50 rupees notes she received is equal to 10, and number of 100 rupees notes she received, we have taken it as y. That means that will be equal to 50. Now in fifth part, our lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid rupees 27 for a book kept for 7 days, while Susie paid rupees 21 for the book she kept for 5 days. Find the fixed charge and the charge for each extra day. We are taking the fixed charge for the first 3 days as x and charge for each extra day be y. Now Sarita paid rupees 27 for 7 days. Now charge paid for 7 days was rupees 27. Now that will be the sum of fixed charge plus charge per day equal to 27. Now some fixed charge was rupees x and that was for the 3 days, and she kept book for 7 days. So charge per day will be taken after, will be charged after the 3 days. That means that y will be charged for 7 minus 3 days, and that will be 4y. X plus 4y equal to 27. Similarly, Susie has paid rupees 21 for 5 days. Now that means for first 3 days she has paid rupees x, and for the next 5 minus 3 days she has to pay rupees y, and that will be x plus 2y equal to 21. Here also the coefficient of x is equal, so we will subtract equation second from equation first, and on subtracting equation second from equation first, we are getting 2y as 6. That means y equal to 3. On putting the value of y in equation first, we are getting x plus 4 into, in place of y we will take the value of y, that was 3, equal to 27, and that is giving x as 15. Thus we can say that fixed charge is rupees 15 that we have taken as x, and the charge per extra day was taken as y, that the charge for per extra day is equal to 3.